This problem says a motorcycle daredevil is attempting to jump across as many buses as possible. See it drawing at top of the right column. The takeoff ramp makes an angle of 18.0 degrees above the horizontal, and the landing ramp is identical to the takeoff ramp. The buses are parked side by side, and each bus is 2.74 meters wide. The cyclist leaves the ramp with a speed of 33.5 meters per second. What is the maximum number of buses over which the cyclist can jump? I'm going to change that a little bit. I'm just going to say that instead of the number of buses, we're just going to figure out what is the total distance. By the way, this one is not to scale. There are going to be quite a few more buses here, but the space is restricted, so they kind of made this smaller here in the horizontal. So it's not to scale. Okay, let's see. They have given the 18.0 degrees. I'll be using that later. 33.5 meters per second is given, but I can't write it in for Vx or Vy. I have to multiply it with the cosine of the angle and the sine of the angle. For right now, I'm just going to make a check mark there. There we go. There we go. Whoops, wrong. It's the launch speed. Sorry about that. Oh, by the way, I could actually shift this down a little bit. Okay, what happened to my question mark? There you go. Okay, let's see. Time is not given. We are supposed to come up with the x distance. We don't know the speed with which it lands, and actually we could know that because by symmetry it would have to land with the same speed, and the ramps are at the same height, the same angle. So we could actually say, hey, we got this one here, and we got this one. This one here is actually going to be the same as this one. This one here is going to be the same as this one, except that this one is positive and this one is negative. These two here are both positive to begin with because both of them are going to be right. This one here is going to go up, and this one here is going to go down when it lands. We can calculate those numbers. Okay, acceleration in the x direction is 0 meters per second squared. Time, we don't know that. Time, we don't know that. AY, that's negative 9.80 meters per second squared. And the vertical distance. Well, the vertical distance, they don't ask the vertical distance to the peak. They ask about what is the distance from here to there, and that means the x distance, the range. Well, look at the y distance. It's the same height, so it starts here at the same height. It ends up at the same height, so the height difference between the two over the entire flight is actually 0. Remember that they're not asking about the point up here, the peak. Then we would have to associate y with some kind of value, but it keeps going down to the same level it started with. So overall, during the entire flight, that's what we're interested in, the entire flight, it's 0 meters. Okay, now the way this would turn out is you would use all of this information to come up with time, and then plug it into this one here, and you would come up with x, and there is a whole derivation of that, and it's posted here. And we could actually do it, but what I do instead is I derive what's called the range formula and present that to you in a moment. So this is actually the algebra where we actually do calculate time and then just eliminate it. I say it right here, eliminate time by putting the two equations together, combining them, and eventually we're going to come up with something that is called the range equation, and that's what I'm presenting here on the slide with our problem. So the range equation is negative v0 squared times sine 2 theta divided by ay. And I think my handwriting really is deteriorating here. That's a v. Okay. That way we can even avoid calculating the components here, and all we have to do is plug in 33.5 here, squared sine of 2 times 18 degrees, so sine of 36 degrees, divide by negative 9.8, the two negatives from here and there divide each other, so that for the range we're going to come up with a positive value, which makes sense because the motorcycle is going to the right. In this problem, a horizontal rifle is fired at bullseye. The muzzle speed of the bullet is 670 meters per second. The barrel is pointed directly at the center of the bullseye, but the bullet strikes the target 0.025 meters below the center. What is the horizontal distance between the end of the rifle and the bullseye? So the bullet leaves with a speed of 670 meters per second, and it strikes the target 0.025 meters below the center. So eventually on the other side here it's going to drop by, well, only an inch actually. And then what is the horizontal distance between the end of the rifle and the bullseye? So what we're supposed to figure out is x. What we have given is, because it's being shot horizontally, 670 meters per second. And in the x direction, that's not going to change with no air resistance. We have zero acceleration. And then the y is given here, 0.025 meters below the center. So a negative makes sense because it drops. Acceleration in the y, of course, negative 9.8 meters per second squared. This one here we don't know. That's the end velocity in the vertical, and they don't ask us for it, so we perhaps don't need it. And this one here we do know because it's shot horizontally. The initial velocity is 0 meters per second in the vertical, and time we don't know, and in this case we have to split up the problem into two parts because down here we just don't have enough information. Which one is it? Oh, up here. It looks like we have a lot of information. What we don't have the right information to come up with x with just one equation. The best one we can do is that we say, well, x equals v0 xt plus 1/2 axt squared. This one here is 0. Check up here. But here we don't know the time, so we can't calculate the x. So we have to do something else first, and that's where the second part comes into play. We calculate first time from the second part by actually using the same equation. So y equals v0 yt plus 1/2 ayt squared. And this one here is 0 because the initial velocity is 0. We solve for time on the second part here, so actually I'm going to make a question mark here. We solve for time here, so then once we have it here we can put it in here, so I make a check mark there, and now we have enough information to determine the x. But I better finish the algebra here. So t equals 2y divided by ay, take the square root, equals, the good thing is that as the ay is a negative, so is the y, so negative divides negative, so we take the square root of a positive number. We still come up with a positive and negative result, and we assume that the bullet will hit the target in the future and does not come from the target. So here we come up with the time. Once we have the time, we can plug it in here, times the 670 meters per second, and we come up with a total distance x. By the way, in this case I didn't call it the range because the range equation in the last problem only worked for something that is being shot up and then comes back down to the same level it started with. In this case it is dropping down kind of from its peak height.